All right, so we're now moving on to the next video in section 4C. And this video, we're going to focus on solving two-step inequalities, but a lot of the video is going to focus on our first learning objective, which is going to be solving inequalities with a negative coefficient. All right, we talked about this in class, and now we're just going to go ahead and go through a few questions of practicing this, but also at the same time, going through how to solve our two-step inequalities. And hopefully from the last video, you're just realizing that the steps of solving an inequality are the same as solving an equation. But now we have to remember when it's a negative coefficient, so when we're multiplying or dividing by a negative number, we have a new rule that we have to apply. And then also, we have to just graph our answers at the end. But now hopefully you're starting to see that everything we've been doing for this past month or so is also into play with what we're doing now as well. All right, so we're now moving on to our first example here. And hopefully by now you're realizing that when we're solving inequalities, it's the exact same thing as when we're solving equations, except for there is a new rule that we're focusing on in this video that we talked about last class. And then also, we just have to graph our answers at the end. But everything leading up to that is exactly the same. So when I see this problem, I'd solve it just like it was an equation. So we can do our PEMDAS in reverse. So I see here I'm adding 8, so I know that I'm doing addition. And I also see that I'm multiplying by -3, so I'm doing multiplying. So that means I can not focus on the rest of these other operations. So the inverse of addition is subtraction, and the inverse of multiplying is dividing. So I'm going to go ahead and get rid of this plus 8 by subtracting 8 from both sides. And now I get -3x is greater than or equal to 27. And now I'm going to go ahead and get rid of our multiplying. And we get rid of our multiplying by dividing. So I'll divide each side by -3. But now is where we have to remember that rule. When we're dividing or multiplying each side by a negative, remember, when we're multiplying or dividing by a negative number, we're jumping to the opposite side of the number line. So on the positive side of the number line, the larger numbers are the greater number. But on the opposite side, so on the negative side, those quote unquote larger numbers are actually smaller now. So when we multiply or divide by the negative number, we have to then flip our inequality because we're jumping to the opposite side of the number line, as we talked about in class. And jumping to the opposite side of that number line, the characteristics or traits of those bigger numbers change. What was once bigger in the positive side is now smaller because it's further away from zero on the negative side. So we have to remember to flip that inequality. That is the one new rule that we're learning that is different from an equation that we have to apply every single time. And once you isolate your variable, then we're going to go ahead and graph it. So I'm going to put -9 right in the middle of my number line, and then it's -8, -7, because I'm adding 1 to each side, -10, and -11. This is going to be a closed circle. And then since it's less than, I know that these numbers to the left are less than -9, so that would then be our graph. All right, let's move on to another problem. All right, so here we have -x/2 minus 6 is greater than -25. All right, so once again, we're going to solve this just like we were before in the past. We're going to do our PEMDAS, and you don't have to write this out every time, and I'm going to actually stop doing this pretty soon because we've been practicing this enough now. But for now, I'll keep on doing it. So remember, we're doing PEMDAS in reverse. Well, here we have -6, so I know I'm subtracting. And here we are dividing, so I'm going to highlight that. I'll cross out the rest. And let's just go ahead and map out what we're going to do. Well, the inverse of subtraction is addition, and the inverse of division is multiplying. So when I see -6, I will add 6 to both sides. So now I have -x/2 is greater than -19. And now I'm going to go ahead and multiply each side by that -2 to isolate that variable. And remember, when we multiply each side by a negative, we have to flip our inequality. So now it becomes it's less than 38. Right? Remember, it doesn't matter what the sign is of the number that we're solving. It's what we're doing to isolate. So as long as if we're isolating a variable and multiplying and dividing each side by that same negative number, then we know that we have to flip our inequality because we're jumping to the opposite side of our number line. So now once I isolated my variable, I can put 38 and now 39 and 40, 37 and 36. This is just going to be an open circle because it's not equal to, and it will then be going to the left for being less than. All right, let's go ahead and do a couple more. All right, so here we have negative 5 times 2x plus 3 is less than or equal to 35. All right, so remember, just like we would with our equations, I'm going to simplify this first. Now, there's different ways you can go about solving this, as we showed you with equations as well. But one of the things I always said is we look to simplify first, and through simplifying its distribution and then combining like terms. So I am just going to distribute this into our parentheses to multiply. So negative 5 times 2x is negative 10x, and negative 5 times 3 is minus 15, and that's less than or equal to 35. And the reason why I wanted to distribute this and not divide on both sides right away is to show you that I didn't multiply that 35 by negative 5. I didn't do multiplication to both sides of that inequality. So I'm not flipping it right now because I'm only simplifying one side of this. So if I'm just simplifying and it's just being done on one side, it doesn't flip. It only does it when we're multiplying or dividing both sides by that negative, because that's the only time that we will be able to truly change their characteristics. All right, so now from here, I see that I'm subtracting and multiplying. So I'll add 15 to both sides. So negative 10x is less than or equal to 50. And then I'll divide each side by negative 10. I'm going to put the answer over here. So x, since I'm dividing by the negative number on both sides, I need to flip my inequality. So x is greater than or equal to negative 5. And then to graph this, we have negative 5, negative 4, negative 3, negative 6, negative 7. This will be in closed circle because it's equal to, and it's greater than, so it will be going to the right because all the numbers on the number line are greater than going to the right. All right, that we will have one more example, and that'll be it for this video. All right, so here we have 6x minus 14 is less than 8x plus 22. So just pointing out and showing you that the more and more examples we do, the more you can say, okay, this is identical to what we're doing with the equations. Now, the thing is, when we are solving with inequalities, sometimes we want to be a little bit more strategic on where we move our variables. So I'm going to show you how to solve this in two different ways. All right, I always like to move mine to the left, just because the way I always do it. So regardless if it's an equation or inequality, I'm always going to move my variables to the left. So I'm going to move this 8x to the left by subtracting. So I'll subtract 8x from both sides. They cancel out. So now I get negative 2x minus 14 is less than 22. Now I'm just going to solve it like a regular problem. We'll add 14 to both sides. So negative 2x is less than 36. And then I'm going to go ahead and divide each side by that negative 2. And now when I divide by the negative, I need to remind myself to flip that inequality so it's greater than negative 18. So I'm going to go ahead and plot my number line. So I'm adding by 1 each side, and then I'll subtract by 1 to go to the left. This is going to be an open circle. It's greater than, so it's going to the right. All right, so that's one way we can solve it. And sometimes, though, people want to avoid that negative number. So the other way that you could have done this is, instead of always just going to the left, you can be strategic. And I can see that I have more variables on, or more x's on my right. So that means if I subtract the 6x and move my variables to the right instead of to the left, I'm going to keep a positive number and I don't have to worry about flipping anything. So you'll see it's negative 14. It's less than 2x plus 22. And then I'll subtract 22 from both sides. So now I get negative 36 is less than 2x. I'm going to divide each side by 2. And since it's positive, I don't need to worry about flipping anything. So now I get negative 18 is less than x. Now, the only problem with doing this is usually we graph when we read these left to right. So someone might read this and say, oh, negative 18 is less than x, and mistakenly draw their arrow going to the left. So if you are to do this, I just highly suggest that once you get down and you isolate your variable, always write your variable on your left-hand side. So I can write my variable and my number like this and just leave it blank in the middle and say, okay, my sign, my inequality was opening towards my variable, so I need to make sure it's opening towards my variable here, so that this way it's written on our left-hand side at the end and we can read it like we naturally do. A lot of times people will graph the graph wrong here because they would read it left to right like we do, but we're always comparing our number, or we're always comparing our variable to the number. So we're saying our variable is greater than here, because remember, this line represents all the numbers that we can actually plug in. So if I were to plug in any of these numbers to the left, well, negative 20 is not greater than negative 18. And that's why it's also important that we test our numbers like we did in the other videos. All right, so that's it for this video.